Hello everyone, my name is Sebastian, I'm the technical lead at yWorks, and in this webinar I'll be talking about tools that yWorks provides that help you create bespoke visualization tools for complex data. I'll quickly introduce you to CovidGraph.org. It's a non-profit organization that uses graph technology to create a knowledge graph around COVID-19. We help build a custom exploration tool with our visualization library yFiles for HTML to explore the data. I will use this app, which is available as an open source project on GitHub, as an example to show you what tools we were using for building it. We will be looking at our free online data explorer tool for Neo4j database schemas and how it can be configured to create a simple visualization app. Then I'll introduce you to our newest online tool, the yFiles app generator, which is a rapid application development tool that allows you to create bespoke yFiles powered visualization apps using low-code techniques only. And lastly, we'll be looking at how the CovidGraph Visual Graph Explorer was built with full code techniques. I hope that after this webinar you will have a better understanding of the tools that we provide and the options you have when you need to decide what approach works best for your projects. At the end of the webinar, I will answer the questions that you may have. Please do use the chat function to ask your questions. My colleagues will be moderating them and I will answer the ones that are relevant to a broader audience right here at the end of the session. We'll get back to you in private chat or after this webinar via email to answer your other questions. So let's go. Let me start by introducing you to the CovidGraph project. The project was founded earlier this year in response to the global pandemic situation. It's a collaborative effort of a group of people who were connected through their use of Neo4j in their daily work. You can find more detailed information on the project's website, but here's a quick overview. Researchers around the world are publishing huge amounts of research data around COVID-19, coronaviruses, etc. And the group wanted to help with analyzing the data and making it more accessible to other researchers. The members were quick to set up a Neo4j instance and loaded all of the data sources they had access to into it. This became our knowledge graph. Using a publicly available database interface, this enabled us app developers to conveniently query the available data from those many different sources around the topics of medical publications, patents, biomedical databases, and more. The different datasets were connected in the database using both simple text matching algorithms as well as natural language processing and named entity resolution algorithms, forming a network of millions of interconnected items. The CovidGraph project provides a number of apps that connect and query the database, and we'll look at one of them that we created for using our visualization library later. The database has a relatively complex schema. Most graph databases, as you probably know, are basically schemaless. But of course, most of the time the data is structured and can be queried according to an implicit schema. We can use the yWorks Data Explorer to get an understanding of the schema and to develop bespoke apps on top of that schema. The Database Explorer can also be configured with no-code techniques to act as a simple visualization tool. So let's have a look. All you have to do is direct your browser to yworks.com/neo4j-explorer. The app is hosted on the yworks.com website, but it's a static web application, meaning that it directly connects from your browser to your database and does not use an intermediate server. This works using the official Neo4j Bolt driver, which is a JavaScript implementation of the so-called Bolt protocol, which allows developers to run queries against the database directly from the browser without going through a separate server. Thus, you don't need to worry about your data leaking outside your organization when using the tool. You can even disconnect from the internet after you started the app and then use the app offline. As long as you can connect to your database, it will work without a connection to the internet. After startup, you give it the connection credentials of the Neo4j database. You will find the credentials for the CovidGraph.org project on their site. After connecting with the database, the app starts by parsing the schema of the database. This takes a while for the complex schema of the CovidGraph project. But once it's done, you can conveniently browse the schema. And with the different automatic layouts, we have, finding a visualization that helps in understanding the structure of the schema is easy. You can look at the various relationships and the nodes, and also what properties are associated with them. You will also find information about full text indices, constraints, etc. One of the central data sources for the CovidGraph project is the papers entity. It represents scientific publications and preprints. As you can see, a paper is associated with authors, references, an abstract and an optional body text. These aren't modeled as properties of the paper node. Only properties where there's at most one value is stored with the node itself. Instead, there are typed relationships to other nodes. Let's have a look at one of these connections. In this specific database, papers are connected to hub nodes. For example, the body text collection is a node that connects with all the sections of the full text body of the paper. Each body text node has a number of fragments. There's a specialty in this schema of the CovidGraph. There are fragment nodes that represent text fragments within the sections. But some of the labels we have are only used as combinations of node labels. This means that the actual nodes in the database have more than one label. In this case, the fragment label is used in conjunction with one or more of the many from prefixed labels. The Schema Explorer tool allows us to clean up the schema to show us which label combinations are used in what constellations. Let's select all of the fragment labels and then ask the tool to split up these labels. What we get is a much simpler schema. Now the paper connects to a body text collection, which connects to body text, which only connects to one type of fragment. And this is, maybe not so surprisingly, the fragment from body text label combination. From this, there's a mentions relationship to gene symbols. So basically this is a relationship between a paper and the genes that are mentioned in the paper text body. So let's verify this with the help of the other major part of the application, the Explorer. We can switch to Explorer view and choose to start with random nodes or search for some nodes to start our exploration. Let's look for a specific node. We search for a paper with a title that contains, for example, the fragment angio. There are many results and we can use a second level filter to find paper nodes that also mention ACE, which is a gene name. I can choose which elements I want to see in my diagram and then include them in the diagram. Clicking on the node, I can see all of the node details in the property pane on the right. Opening the context menu on the node allows me to iteratively explore the network. I can choose to incrementally load nodes by either their label or by their relationship type. Let's load the body text collection. There is only one. But this one has 24 body text nodes. Let's load a few with ACE again. And from there, we finally get to the mentioned gene symbols. If there are multiple fragments mentioning the gene symbol, we would get to see multiple connections. We have now unrolled the multi-hop relationship between a paper and the genes that it mentions. But wouldn't it be cool to get rid of all the intermediate nodes for the purpose of the visualization and just see the connection between the papers and the genes? Let's go back to the schema. We find the paper node again, and then we create a virtual multi-hop relationship. This does not affect the database and is only used in memory in the app. Via the context menu, we choose Create Transitive Edge. And then we connect the nodes we're interested in. via body text, the fragment, up to the gene. When done, we finish this step and we get to see a dialog where we can see the cipher query that we implicitly created. We can give our new relationship a name and then go back to the schema. We see our edge has been inserted into the schema view. Now when we go back to the Explorer view, we find the new relationships shown in the diagram. We can now remove the elements in between and only see the new connection we created. Also, in the context menu of the node, we now get the option to load all the mentioned genes for a given paper. There are many more genes mentioned in this paper. Unfortunately, by default, the name of the gene is not shown in the visualization. That's because the app uses a heuristic to decide what properties to display initially. And since in the database we are using some unusual property name for the name property of the gene, it's not being displayed. In this case, it's SID. If, however, we want to see the name of the gene in the visualization, we can define a custom visualization template. This can be done on this tab. Here we can select to create a new template. We specify that the template should be applied to all gene symbol nodes, and then we can edit the template. This editor allows us to add arbitrary static and data-bound images, geometric shapes, and texts, and so on. Let's just add the label to the standard template. For this, we drag a text element onto the editor and position it to our liking. Then we change the static text to a data-bound property. The node properties from the database are stored in tag.properties and then it's SID. As you can see, this renders the label from the data on the node. Let's also quickly add some geometric shapes, an image, and change the color, just for the fun of it. Close the editor, and that's it. There's much more we can do in the Data Explorer, but it will always stay an app that is hosted online and is a generic tool. Now what if we wanted to create our own tool? How difficult would that be? Can we use low-code or even no-code techniques to create a custom application that is specific to our data and for our use cases? We can. We have recently been working on another amazing tool, the yFiles app generator. It allows you to do exactly that, create bespoke graph-powered visualization applications without having to write code. It's also built on top of yFiles, and the applications it generates use the powerful yFiles API to display the graphs. But with the app, any engineer can create applications without programming or even looking at the API or the documentation of the library. You can use the tool to interactively load data from various data sources, then transform that data into a graph structure and visualize it. Finally, you can export your setup as a ready-to-deploy application. The yFiles app generator is already online, but still in its early stages and work in progress. Please go and give it a try after the webinar though, and do give us your feedback. It's already useful and really fun to use, so let's see it. This is the yFiles app generator. We can use it to define a data processing flow and ultimately create a custom application. I have some sample JSON data on my GitHub gist that I'll be trying to render as a graph. It's just a very simple and small JSON structure with an array of nodes and some edges. We start by dragging this web loader node onto the canvas. Clicking the node opens the property panel and shows the available configuration options. I will paste the URL here, and I can keep defaults for the other options. Using the hover spy over the output pin, I can see that the result of the web load was a simple string. I'm going to transform that string constant into a JSON object. So I take the JSON node and connect the input pin with the string output. This now gives me proper JSON objects to work with. Using the hover menu, I can inspect the data conveniently. As a next step, I will split up that JSON into two arrays of objects. One is the nodes array. The projection node lets me define a binding inside the object that will pick the collection from the full JSON structure. I do the same for the edges property. Now this gives me two separate collections of node and edge objects. I can inspect them and scroll through the elements using the hover spy. Next, we need to tell the engine that these arrays of objects are actually used for the creation of the nodes and edges in our graph. For this, we add these nodes and edges source nodes to which we connect the respective data. These data sources for nodes and edges can then be fed into a graph builder processing node that combines the data and connects it to an in-memory graph model. Each of the nodes and edge sources can be associated with so-called node creator and edge creator nodes respectively. They will determine how the graph items appear in the resulting application. However, in order to show the graph, we're going to first apply an automatic layout algorithm. And finally, we tell the generator that this graph is the result we're actually interested in and that we would like to see in our resulting application. In order to make this work, we need to configure the data sources and specify which JSON properties identify the elements via IDs. I can enter the binding for the node IDs here. Edges reference the nodes in this case via S and T properties. Now what's left is how the nodes should be rendered in the visualization. I can adjust the appearance of the nodes, for example, to make them larger or change the color. We can already see the nodes represented by these rectangles. Let's also configure the visualization for the edges. If we take a closer look at the data, we see that there's a label property that we can use in the visualization. We can add any number of labels for nodes and edges, so let's just add one for the edges. This could be a static text or a dynamic binding like in this case, or it could be a combination of both. Nodes in the JSON also use the label property for declaring their labels, so we can just reuse the one label configuration for the nodes too. This gives us labels for both nodes and edges. I run an automatic layout to clean up the graph. Now we can actually preview what our tiny application will look like at the runtime. We just need to hit the preview button to see a preview. But the really powerful feature of the generator is its ability to generate the sources and pack the application in a bundle. For this, we can choose which UI framework we want to use, some options like the component framework, and in this case it's Vue.5 or Vue.js. And we can choose our preferred programming language and also add some out-of-the-box features for our app too. The application will be powered by yFiles for HTML, so we also provide the node module package and version we want to use, as well as the license file information. This will ultimately create a zip file with the generated source code that we can then fine-tune or bundle and finally provide it to our end users of our app. And since this is all just source code using our preferred framework and language of choice, we can then use the powerful yFiles API to conveniently add more features to our simple application. After building and deploying it, it will render the graph exactly like we've seen it in the preview. I will show you that later with the next example, which will be using the CovidGraph data instead. You might have seen it already. There's this telling Neo4j loader node that we can use for this purpose. Of course, we need to provide it with the credentials for our database and all that configuration. Let's go back to the Data Explorer for Neo4j app. The app already knows the credentials and connection properties as we have entered it the last time. And more importantly, it also knows how we want to visualize the elements in the graph. I added custom visualizations for genes and papers already. Let's reuse that work. I can simply export the app settings to a settings.json file, which we can then import into the app generator, which understands this format. It will automatically configure a flow graph from the settings files. There is still an error in the project. The way I exported the settings, it did not contain the password and username, so I need to fix that here. And since in this specific case the database runs on an older version of Neo4j, I also need to switch to using the bold scheme. After this, we can specify a starting Cypher query that will be run on application startup. I just modified it to load some paper nodes. And when we launch the preview, we can see the papers styled in the way I configured them in the Data Explorer app. The query as such is not very sophisticated though. So let's try the more interesting query about the genes mentioned in papers. When we were creating the transitive edge in the Data Explorer app, in the final dialog, we saw the structure of the Cypher query for the transitive relationships. Note that button, which allows us to copy the query to the clipboard for use in other tools. I can just paste that query into the Cypher input field of the app generator. The query could be arbitrarily complex, and I can even parameterize it through the interface. Here, I will just modify it to return all of the elements referenced and limit the number of results. Now, we actually get a connected graph with a few relationships, using the symbols and data-bound visualizations that we customize in the Data Explorer app. And all this using no JavaScript or TypeScript code at all. Again, let's bundle this as an application. This time, the application bundle will also have the Neo4j driver as a dependency in the package.json. So that all that needs to be done is an npm install to get the app up and running. Let's see how that works. I unzipped the zip file, opened it in my IDE, and with the pre-configured package.json file, I was able to install the required modules using Yarn. This added the Neo4j bolt driver and the yFiles library to the app. All that is left now to do is to serve the app. So let's do that and see what it does. While it prepares the bundles, let's take a quick look around. This is a Vuetify-powered Vue.js application written with TypeScript, with a simple toolbar, and of course, there's a graph component. By default, there are some actions defined that will be available as buttons in the UI. And let's see it. Wait for it to load, and here is our graph. For fun, I configured the graph to be editable, so that you can see that this is actually an interactive app. I can create new items, relationships, etc., and perform undo, redo, and so on. And since this is all available as a source code, I can use the powerful API of the diagramming library to add more features or change the behavior to suit my exact requirements. For example, in order to apply a different kind of automatic layout. With the Webpack build and the enabled hot reload, the code changes get applied immediately. In this case, since my query only resulted in 3 relationships, this of course does not lead to a very interesting result. But it only took me minutes and literally just 1 line of code to create it. You can imagine that if we invest more time into it, the result will be far more impressive and useful. So this is what we did for the CovidGraph project. Note that we did not use the ETL tool that I just showed to you, because at that time it wasn't available yet. It uses the same underlying technology though, and actually it is our declared goal that after some work on the generator tool, it will be able to scaffold an application like this too. This tool here also connects directly to the CovidGraph database and was authored using a combination of Vue.js for the UI and yFiles for the diagramming part. Let's see how it works. We added a custom search box to the top of the application where users can pre-select the type of entities they are looking for. Then you may enter a search query, and depending on the type you are querying, this will either be going to a Neo4j full text index, or it will be using a parameterized cipher query. Once you entered the search string, this will execute the query and fetches the results. If there's more than one item matching the query, we get to see a preview where we can pick the items which we want to see in our diagram. That's very similar to what we had in the generic data explorer for Neo4j app. This loads the elements on the screen. We can add more elements on the screen using the queries above. For each node type that we load from the database and visualize on the screen, a separate SVG template was created that shows the most important information to the user right in the visualization. We use level of detail rendering to remove information from the visualization if we zoom out, or add more information when we zoom in or select an item. Additional information is shown in the details panel on the left-hand side for the currently selected item. In contrast to the generic Data Explorer app, this app can show more than just the immediate properties of a node. For example, in the case of the paper, we can see the full text directly in the side panel. We can possibly get a link to the publication, and we also get a preview of some of the associated entities, like the mentioned genes and the authors, which are actually separate entities in the database and in the visualization too, and they can be added to the diagram with a convenient interface. Also, there's this load context menu, which mirrors what's available in the context menu of the diagram for selected elements. Similar to the Data Explorer, we can explore the neighborhood of the element, but this time we're using clear descriptions for the menu entries and only show those entries that are important for the use case the app has been created for. You can also see that we have the transitive relationships again in this app. There are a few powerful queries that you can perform through the app interface. They were built in response to a specific use case and added to the graph, but you will see that they are still relatively generic at their core and can be reused for other apps in just the same way. So let's go through some of them. Let's say as a researcher we have been reading this publication. We have seen that it mentioned these two genes, ACEH and ACE2. We would like to learn more about these genes and find other publications that also mention these genes. If we were to simply look for publications that also mentioned ACE2, we would quickly be lost because there are so many papers talking about this gene. Luckily, we can use the power of graph technology to find publications that mention both of these genes at the same time. In the app, we can actually search for all types of common neighbors if we select one or more items of the same type. And sure enough, it will come up with another paper that mentions both genes, and that we should go and read. Basically, our knowledge graph worked as a recommendation system for us. Here's another slightly more complicated situation. We know that the ANG gene is involved in this pathway, and it's encoded by this protein. Now, if you would like to know which other genes are related to this pathway and at the same time are encoded by that protein at the top, we can select these two elements and find other genes that connect the two other types. Graph technology again helps us find the results. This involves a pretty complex cipher query, which is very difficult to write manually, but it's just 2 clicks in our app and the results are easy to read from the diagram. Let's have a quick look at how some of the features I just demonstrated have been implemented. The application source code is also on GitHub with the CovidGraph organization. So if you want to have a look at the sources or even modify them and build your own version, the code is online with build instructions included. For this app, there's quite a lot of code involved and it took us several days to implement it. But you will see that what we've built can be easily adjusted for your own specific use case, because most of the code is very generic and can be put to use in other explorative graph apps just the same. The code that generates the UI and manages the cipher queries, connects to the graph visualization library, etc., can all be reused and you don't need to bother with it. But still, in order to be useful, the app needs to be aware of the schema specific to the database it connects to, in order to provide the answers to use case specific questions quickly. Those parts that deal with the database specific schemas and entities are separate from the rest and can be modified easily. Let's see how this was done. Basically, what the application needs to know is what aspects of the data should be presented to the user and how. We need to teach the app the schema of the diagram. We learned about the schema from the Data Explorer app I showed you previously, and we've seen how we can use the former app to create cipher queries for the more complex multi-hop relationships. Let's see how the entities and their connections in the diagram were declared in code. There's this one central CovidGraph loader JavaScript file, which contains all the customizations for the CovidGraph schema. It tells the app what entities there are. We need to pass in the Neo4j node labels so that they can be identified in the cipher queries. We also need to specify how the nodes should be visualized in the diagram and at what sizes. For this, we can use the same data-bound templates that we've seen in the other tools, and of course, we can add more to them and use the power of the web platform to create a rich user experience with CSS animations, transitions, and styling, and so on. For a simpler styling, there are more options available here. We can add more text labels on top of the visualization and specify what should be seen on the tooltips when the user hovers over the elements. And for the table preview results you've seen, we specify how the results should be rendered and what columns should be shown on the screen. And should we need to use a more sophisticated cipher query for loading or searching the entities, this can also be specified here. For each different type of entity, one such section needs to be added to the app in this way. Likewise, in order to specify the connections that users should be able to traverse and explore in the visualization, we declare them in a similar manner with a separate method call. Of course, we could use a very simple cipher query to load direct neighbors in the database, but we can also reuse the queries we obtain from the Data Explorer and add conditionals to let the user quickly find those entities and relationships that they are looking for in the data. Again, for the edges in the diagram, we can also add tooltips, style the connections to our liking, adjusting strokes, colors, labels, arrowheads, and so on. This is all that is required to get the automatic search and the filtered result views for exploring the neighborhood of the nodes. And this is actually also all we need to do to also automatically enable the common neighbor search option I just showed. The app assembles the more complex queries from the basic queries we provided here. Then, when the user selects multiple elements, the app will automatically search the schema to find and generate the correct cipher queries to find the mutually connected elements. Lastly, to enable the missing link searches, we only need to specify which pairs of relationships we want to intersect to enable that additional context menu entry. This is what happens in these lines of code. And that's it. So to summarize, by using yFiles for HTML and by actually writing code, we were able to connect to arbitrary data sources. Even multiple data sources or live data sources that push updates to the client are possible. We can apply custom automatic layout for the creation of meaningful layouts. Even though in these examples only very simple layout algorithms were used, for other data models and domains we could be using much more sophisticated automatic layouts that encode information that the end user is interested in directly into the diagram. We were able to generate bespoke item visualizations that show just the right amount of information to the user. And we can add interactivity to our applications that helps users navigate the data intuitively and find answers to the questions they have quickly. So when should you use what? No-code tools, low-code? And when should you be implementing an application using traditional coding? There's no generic answer that will fit all use cases. but I hope that I was able to give you some ideas for your next visualization projects. There are definitely situations where no-code tools can be of great help. Often they require little to no setup, and you get results very quickly. This usually comes at a usability cost though, because most of the time this stays a generic application with a generic user interface. With a little bit of coding and with the help of some low-code techniques, you can create a much more customized user experience that better suits your use cases. In many cases, this is what you should aim for. If you know that you have a very specific requirement, I still believe that creating a bespoke visualization app using code will give you the best results. And for a lot of non-trivial projects, this may very well be the only feasible alternative. So now it's time for your questions. I hope you ask them in the chat. So let me see whether I can answer them. Yeah, there's one. What other databases can the app generator connect to? In the sample we've been using Neo4j, so that's obviously one option, but that's only because we just started implementing it. So there's I think it's 4 ways at the moment to load the data. One is to simply to load the data from a string constant. So for testing purposes, you may just paste your data into the project, and we will then load and transform that data. And also we have added random data. So just for the fun of it, if there's this option to generate random data, and for those of you who don't have any data sources at hand and want to play with the tool, you can use that one. Since we are using the Neo4j Bolt protocol, this doesn't mean that you have to use a Neo4j database. So as long as your database supports the Bolt protocol, you can also use other protocols, other databases. And obviously, as I showed you, you can load the data from a URL. This doesn't have to be static JSON files. It could be JSON and CSV files currently in the application, but the JSON can of course be generated by some REST API or custom API that yields your JSON data or connects to your data source on the server. For example, we successfully connected to Sparkle endpoints, which is also a query language, via the WebLoader node, and were thus able to connect to some other great graph database too. We have actually plans to add support specifically for GraphQL endpoints, and maybe some other database protocols too that are then accessible from the web also. So there's more to come. But it's still specifically with the WebLoader node, there's a lot that you can do already. But if you're a developer, this doesn't mean you have to wait for us, because you can just replace the static JSON data import to instead, query your own data sources using any custom protocol, and that's the power of writing code and using an API in the end. So you're not restricted to the API endpoints that we have been thinking about. Yeah, there's another question. Can the app generator also generate desktop applications? Yes, it can actually. Until now, what we have, it only produces TypeScript and JavaScript. But you can use technologies like the one Visual Studio Code is using to embed a generated web page application into a standalone desktop app, for example. But we also plan to natively support the yFiles for Java Swing and JavaFX, and also the WinForms and WPF versions of yFiles. So that would enable you to actually generate projects for these platforms directly, and then that would allow you to use C# and Java instead of just JavaScript or TypeScript. Yeah. Okay. Will you open source the app? No. Well, yeah, we have plans to actually provide the sources for the flowchart editor part of the app. So if you're interested in creating an application that also allows users to create flowcharts, then you'll be happy to hear that we'll be providing the app generator as a source code demo for yFiles for HTML in one of the next releases. So as our customer, you will be able to write similar looking applications. However, the parts that deal with the actual code generation, which are really specific to this generator, I don't think we're going to publish them. But should you be interested in specific aspects of features of the application, just do let us know, and well, we'll see what we can do. And by the way, the code that the app currently generates is under the same license as our demo file, so our customers can modify it to match their specific requirements, and then just deploy the app under the usual royalty-free yFiles conditions that we have. Okay. So for more questions and answers, please do contact us directly, or be quick and type it into the chat. There were a few questions I didn't answer now. If yours wasn't, then we're going to answer them. We'll get back to you soon via email if you leave us your email in the chat, or via the registration. And a recording of this webinar will also be put online soon for you to replay and then share with your team. So, well, I'd say that's it. Thank you very much. Thank you for attending this webinar. And as we say always, happy diagramming with yFiles, and bye-bye. Stay safe.